We'll see today some additional operation. So in the last few classes, we have seen the operation related to the relational algebra, which were related to select, project. Then we have the uh, set difference. Then there is a Cartesian product and rename operator. Okay, and today we'll see some more additional operation related to the relational algebra, and we'll see that how this query will be written in SQL as well as from SQL how we can convert into relational algebra. Now from the additional operation, this is the first operation, that is called set intersection. Uh, Set intersection is used if we have two relation and we want the common element from these two relation. We'll use the set intersection. This is the symbol for the set intersection. Natural join is just a natural join phenomena where we have two table and two table will be joined together with some common attribute. So this is the symbol for that. Then we have the aggregation. We'll use some aggregation function, and that aggregation function will use and will put in the form of some symbol that is called in this form. We'll do that. It look like G. Then there is a outer join. We have three type of outer join available. So the first one is called left outer join. This is my left outer join symbol. Second one is called right outer join. This is the right outer join symbol. And then we have the full outer join. So this is your natural join, and then there is a symbol of full outer join. So these are different operator that we'll use for the outer join. Then we have the division operation. Division is just like this, a proper division, how we'll use it. In all these, aggregation are the only additional operation that we'll use, which are the basic operation. Other than that, all are the operation that will be derived from the basic operation that we have seen earlier. This is an example of the set intersection. If we have two relation 1 and R and relation S. So if I want the set intersection of this, so it means that whatever the common element are, so we have this common element that will be taken as output and rest of the thing will be discarded. This is your set intersection. It's just like your intersection. So how we'll get the intersection, that is the meaning of this. Then we have join, in which first we'll go to the natural join. So in SQL, you might have learned about the join. We have different type of join available. So we have inner join, we have outer join, we have natural join, we have cross join. Okay. So what is the meaning of natural join? So the meaning of natural join is when two tables are there, two relation is there, and when we want to join two relation, there should be some common attribute that is present in both the relation. If they are present in both the relation, based on that, if we are joining two tables, that is called natural join. Okay. So if we'll see some of the example of the natural join, so that could be better if we'll see that some of the example of natural join. So we have these type of join. Okay. Cross join is same as your Cartesian product. Natural join is same as your natural join. There is an inner join or join we have. Then we have self join also. Means one table is comparing with its own element. Then we have outer join, in which we have different type of outer join. So as you can see in the SQL, all these are different type of join available. And if you see, the inner join is different, totally different. For the natural join, this is the symbol. For the cross join, this is the symbol. For left outer join, this is a symbol. For right outer join, this is a symbol. And for full outer join, this is the symbol, right? If you see this example, that select asterisk from table, join other table on table ID equal to other table foreign key. So what it is saying is this foreign key and this ID are the two attribute, based on that we are joining it. So that is join. Either I can write simple join or I can write inner join with some condition, right? So what is the basic concept here is, here we'll write the SQL query in this way: select asterisk from, let's say, table 1, join table 2 on, and on will have the condition like table 1 dot, let's say, ID equal to table 2 dot ID. So what it is saying, what it is telling to you, it is telling that we have table 1 and table 2, but both are joined with some attribute, okay? This not like, it is not necessary that it should be the same as this one, okay? The name need not be same, but it is necessary to be same if we are doing natural join, okay? Natural join is something different. How I'll write natural join? I'll write select asterisk from table 1, natural join table 2. Here I haven't used on, if you can see. Now what it will do is, compiler will see table 1 and table 2 and find the common attribute. And based on that, it will apply the equi-join operation, right? This is the join operation that it will apply. See, here it is equal to, you can make it less than, you can make it greater than, you can make it less than equal to, greater than equal to, whatever is condition you required, you can make it. But the natural join is always make it equi-join. Means table 1 has and table 2 has, it will find out what is the common and it will make like this, which is written here. But we doesn't have to write it, okay? You can write this much only, it will work. For the two table where we have defined uh, primary key and the foreign key concept, we have applied there at the time of creation, it will work. There is no issue on that. Okay, this is no natural join. I want to tell you the difference between the join and the natural join. Now if you come to the relational algebra, in the relational algebra, if we have a relation R and if we have relation S, we want to do a natural join, I'll write the symbol, that's all. If you want to see the SQL part of this, which is written here, it will be like this. Select asterisk from R, natural join S. That's all. This is the same as this is the same as this. Getting it? Right? Now the same query I can write in a different way also if we require. If we have this RNS, if you can see this RNS has two common attribute B and D. Here also we have B and D. Okay, two common attribute. And based on that common attribute, if we are joining it, so we have to join in a different way. So let's say I am writing a join operation with this. How I'll write? If I'll want to do natural join, so what I'll do is first we'll go for the natural join. It will be select asterisk from R natural join S. Okay. Here I have written asterisk. It means I want all the column from both the tables. The thing is that we have BD and BD which is common. So we have to tell the compiler that which particular column I want. Which particular column I want. I want this column or I want this column. I definitely I want A, B, C, D, E, but which B I want? I want B from R or B from S, or I want D from R or D from S. That I have to tell here. So in which way I'll tell? I'll write here select R dot A, R dot B, R dot C, R dot D, and S dot E. What is the meaning of that? The meaning is I want A from table R, B from table R, C also from table R, and D also from table R, but E I want from table S. And I don't want the B and D from S. That is the meaning of this. Second way, how I can write the same query with other type of join, I'll use the inner join for that. So for that, I'll use the same thing, select, and I'll either use the asterisk or use the same thing, which I have written here, okay? I'm not writing the same thing again and again. From R, let's talk about inner join. It will be either you write inner join or you write join. Join S on what basis we want to join. So we want to join based on R dot B equal to S dot B and R dot D equal to S dot D. This is my query if I am using the inner join. Let's say I don't want to use inner join. Let's talk about if I want to use cross join. So how I'll write this same query. Select and you write all these things from R comma S. This is my cross join, okay? R comma S, where the same I'll write R dot B equal to S dot B and R dot D will be equal to S dot D. Getting it? So this is the example of natural join. This is the example of inner join, and this is the example of cross join. So the cross join, which is I'm writing it like 1, 2, and 3. So the first one is your natural join. It is same as this. So I'll write the relational algebra for that. It will be R natural join S. That's all. This is your relational algebra. For third, relational algebra is written here. This is the relational algebra for third one. This one. This here we have used Cartesian product. For the second one, the relational algebra would be like this. What is this? This is the join, but we doesn't have these phenomena here. We doesn't have these phenomena here. So what we have to do is we have to make a cross join here. And we have to, so for the second one also, this is the way how we can do that for the second one also. Because in the relational algebra, we doesn't have the concept of inner join. Okay, we have the concept of natural join, we have the concept of cross product, we have the concept of outer join, but we doesn't have the concept of inner join, right? So this relational algebra will be same as this for the second also, for the third also. Okay, so this is a natural join. Let's see the same database again, where we have branch, account, depositor, customer, borrower, and a loan account. And let's see some of the example. The first example is find the name of all customer who have a loan and an account at bank. What it required? It required that the customer should have loan as well as a customer should have account. So how I'll get that record? If a customer is there, so there is a customer name, right? This is a customer name and this is a customer name. This customer name will tell that those customer who have the account because they are the depositor. These customer will tell you that these are the borrower and they have the loan account. So what we can do is we can make a intersection of these two and we'll get it. So we have the depositor table and we have the, okay, so we'll get the customer detail and customer name for that. So how we'll get the customer name? So we'll have to project, right? So we'll project customer name from depositor and we can find the customer name from borrower, right? It will give me the customer name who have the who have the account, and this will give me the customer name who have the loan. And what I'll do is I'll make the intersection between these two. Now what it will tell me? It will tell me that which are the common, who has the customer name, who have the depositor, who have the account, as well as who has the loan. Because the depositor table will give you the customer name who has the loan, and borrower table will give me the customer name who has the, depositor table will give me the customer name who has the account, and borrower table will give me the customer name who has the loan. And it required both, right? Customer who have loan and an account. So we'll make a set intersection to get it. Okay, this is how we can do that. Next is find the name, loan amount of all customer who have a loan at the bank and an account at the bank. So what it required? It required the name, the loan amount. So where we'll get the name of the customer. So this is how we'll get the name of the customer. How we'll get the loan amount. Here we'll get the loan amount. So we require loan as well as borrower, right? Next, the customer who have a loan, it is okay. Who have the customer name, I want the customer name as well as the loan amount. Who have a loan at the bank and an account. It required that it should be an account also. So for that, what we have to do? So for that, we have to involve another table which is called depositor table. So what are the table that is involved here in this particular query? So we require loan table. Why loan table? Because without the loan table, you will not get the amount of the loan. You might get the name of the customer who have the loan from the borrower table, but the loan amount you will not get. So for that, we need the loan table. Then you require the borrower table. Why we require the borrower table? The reason is that we'll get the customer name from here. Here we doesn't have the customer name, but we require the customer name, right? So borrower table will give me the customer name. And you require the depositor table. Why we require depositor table? Because the last query it says that they should have the account also in the bank. So the customer should also have the account in the bank, right? So we required the loan, we required the loan table, the borrower table, as well as the depositor table. All three table we required here for this particular example. So we'll write the query for that. So we'll do the joining, right? But what we required? We required customer name and we required, what is it? Amount, not the loan amount. It is just an amount. Okay. And then we have to join. So what we do is how we can join these three tables. So you can see the table and you can find it out. So depositor and the borrower, what are the common? So customer name is the common, right? So based on the customer name, they will be joined together. And then what is the common behind loan and the borrower? Loan number is the common. So based on that, they will be joined. So what we do is we'll first join these two tables, which is a depositor and the borrower, so that we can get the customer name. We'll get the customer name who have both loan and the account. And then from the loan number, we'll find out those people who have the loan and find out the amount. So for that, what we do is we'll use borrower, make a natural join with the depositor, and then we can make a natural join with the loan account. And from that, we'll get customer name and the amount. The previous question can also be solved with the natural join also. How? What we want? We want customer name. We can make the natural join of borrower and the depositor. So what it signifies? It signifies that we doesn't have a unique query for writing it. Okay, we can write the query for getting the desired output by different ways. So this is the way how we can do that, and this is the way how we can do that. Okay. I'll just erase it so that you can understand it. See, this is for the intersection, as well as you can write it with the natural join. This is with the natural join that we can apply. Okay. Here they have applied the natural join first with the loan and the borrower, and then they have applied with the depositor. So this is one way you can do that, or you can make it depositor and borrower first, and then you can make loan afterwards, right? Now let's go to the aggregation function. So how many aggregation function we have? If you know, so we have different type of aggregation function. We have average, we have min, we have max, we have sum, we have count, right? So all those aggregation function we can use in the relational algebra also. But how we can write it? We can write it with the symbol. This is the symbol for that, in which we can write it. Okay. So the aggregation operator in the relational algebra is this. This is the aggregation operator. We'll write the function, that is the aggregation function, and the column name. So A1, A2 are the column name. This is the relation name. And what is this? This is for group by. If we want to make a group by for any set of columns, for that we'll use it. So let's start with this from here to here, and then we'll go to the group by also, this particular part. Now this is a relation, and in this relation it want the sum of the attribute C. So it will get the sum of the attribute C. So it will use the symbol and then sum and then C, and which is in R. It is same as select sum C from R. Okay, this one and this one is the same. This one and this one is the same. So this is a SQL query. Select sum, and in bracket we'll write uh, the column name, and then from R. It will be the same. Let's see. In this, what it will find out? It will find out the sum balance of the account based on the branch name. Means in each branch, what is the balance right now? So it will make a group by of the branch. So branch wise, it will make a group. So this is one group, this is another group, right? So it will find out the adding of these two balance. It will be how much? $1,300. Here these two, how much it will be? 1,500. And this is the alone, it will become 700. So you can see there is a group by. I want the group by branch wise. So I want branch wise total balance. This is the query. The query says that I want the branch wise total balance in the account, or sorry, in the bank. So let's say we have a bank, the SBI bank in one region, another SBI bank in another region. So what I want is, I want the amount, the balance of each region or each SBI branch. It is just like that. So for that, it has done the sum of the balance, but previously it has done a group by. You just have to write the name of the attribute which you want to make a group. How will write the SQL query for that? I'll write the SQL query. Select sum balance from this is the account table, from account Then I'll try group by. How we are grouping it? We are grouping it based on the branch name. So I have to put the branch name here also. Here, branch name. So the query will be select branch name, comma, sum balance from account group by branch name. Okay. So it will be two column, branch name is one column and sum balance is another column, right? Then we have different outer join that we all know what is the meaning of outer join, right? There are different outer join. So let's say we have two table. One is the loan table, another is the borrower table, or loan relation and borrower relation. Loan number is there, branch name and amount. Customer name is there and loan number are there. If you want to do the natural join, this is my output for these two. So it will make a natural join with one common attribute. So which is a common attribute? Loan number is a common attribute. So based on that, it will do a natural join. Okay. The first one. The first one. So how I'll write the natural join for that? It will be select asterisk from loan natural join borrower, right? This is my SQL query for this. Then we have the left outer join, right? This left outer join, the symbol is this, and it will give me the result, means the left type of loan. So left table is the loan table. So all the data of loan will come, but the condition which will apply here, if it is satisfied, those data will come for the borrower. So we have customer name as the separate column here. Here we doesn't have the customer name, right? So it will come loan number, branch name, amount, and customer name. So customer name will be in the last. Is it coming null? Why it is coming null? Because it is not satisfied. What is the satisfaction condition here? It should be equal to. So which one is equal to? The branch name should be equal to the branch name, right? Sorry. Yeah, loan number should be equal to the loan number. So you can see you will get this particular column along with this. This is your first row. Then 230, here also 230, it is also satisfied. This will become your third row. And 260, here we doesn't have 260. So, but because it is a left outer join, so this will come. This will come and this will become your, sorry, this is your second column row, and this will be your third. Even though this is not satisfied, L26 to 60 is not there. Even though, because we are using the left outer join, this will be coming of the left side table, and because it is not satisfied, the rest will be null. As here you can see, this is your left outer join. Let's talk about right outer join. It's the same as this is the opposite of the left outer join. So here, how it will be look like. In the right outer join, what we'll do is we'll satisfy the right. So this is your first row. This is your second row. Why? Because the condition, these are equal to. And in the third row, you can see it will be not satisfy. So these two will be there, but these will be null. You can see here, this will be null. These two are here, which is 155 and highest. It will be 155 and Hayes, which is a customer name, and rest of the thing it will be null, right? Now in the SQL or in the database, you might have encounter about the null. So what is a null? When we doesn't have the data to put in the field, we will not keep it empty. Instead, we'll put it null. Okay. And null is nothing but a value that we are giving, but you can see that null signifies no value. But we give this null into the field. Let's say here it is coming null. What is the meaning of null? It should come nothing, but it is coming null. The meaning of this is there is no specified value that can accommodate here, but in the database we cannot keep the field empty. That's why it is null.